Measurement of matter. Chemical symbols of elements. Dalton used certain signs to represent elements. For example, a circle with capital C written inside was used for copper. Today we use the symbols determined by IUPAC, that is International Union of Pure and Applied Chemistry. These are official names and symbols and are used all over the world. The current method of choosing chemical symbols is based on the method invented by Berzelius. According to this method, the symbol of an element is either the first letter or the first and second or another specific letter in its name. Of the two letters, the first is a capital letter and the second is small. Molecular mass. The molecular mass of a substance is the sum of the atomic masses of all the atoms in a single molecule of that substance. Like atomic mass, molecular mass is also expressed in the unit Dalton, which is denoted by small u. Let us understand how to deduce the molecular mass of water. Formula for molecular mass is equal to sum of constituent atomic masses. Therefore, molecular mass of water is equal to atomic mass of hydrogen plus atomic mass of oxygen. As there are two atoms of hydrogen and one atom of oxygen, atomic mass of hydrogen is multiplied by 2 and atomic mass of oxygen is multiplied by 1, which is equal to 1 into 2 plus 16 into 1 equals to 2 plus 16, which is equal to 18U, that is 18 Dalton. Concept of mole. A mole is that quantity of a substance whose mass in grams is equal in magnitude to the molecular mass of that substance in daltons. Therefore, formula for number of moles of a substance, which is denoted by small m, is equal to mass of substance in grams upon molecular mass of substance. The SI unit is mole. Thus, the molecular mass of oxygen is 32 Dalton and therefore 32 grams of oxygen is 1 mole of oxygen. The molecular mass of water is 18 Dalton, therefore 18 grams of water make 1 mole of water. Avogadro's number. The number of molecules in 1 mole of any substance is constant. The Italian scientist Avogadro did pioneering work in this context. Therefore, this number is called Avogadro's number and is denoted by the symbol N subscript A. Later, scientists demonstrated experimentally that the value of Avogadro's number is 6.022 into 10 raised to 23. A mole of any substance stands for 6.022 into 10 raised to 23 molecules. Just as a dozen has 12 items, a century has 100, or a gross has 144, a mole means 6.022 into 10 raised to 23. For example, a mole of water, that is 18 grams of water, contains 6.022 into 10 raised to 23 molecules of water. Let us understand the definition of valency. From the diagram given below, we can see that a sodium atom gives away one electron and a cation of sodium is formed. Hence, the valency of sodium is 1. A chlorine atom takes up one electron and forms an anion of chlorine, that is chloride, and thus the valency of chlorine is 1. After the give and take of electrons is over, the electronic configuration of both the resulting ions has a complete octet. Due to the attraction between the unit but opposite charges on the two ions, one chemical bond is formed between Na plus and Cl minus and the compound NaCl is formed. From this, the electronic definition of valency is as follows. The number of electrons that an atom of an element gives away or takes up while forming an ionic bond is called the valency of that element. Variable valency. Under different conditions, the atoms of some elements give away or take up different numbers of electrons. In such cases, those elements exhibit more than one valency. This property of elements is called variable valency. Some elements that exhibit variable valency are as follows. First, copper exhibits the variable valencies 1 and 2. Mercury exhibits the variable valencies 1 and 2. And iron exhibits the variable valencies 2 and 3. Chemical formula of compounds. The steps for writing a chemical formula of sodium sulfate are shown below. Step 1. Writing the symbols of basic radical on the left and acidic radical on the right. Here, sodium is the basic radical which is written on the left and sulfate is the acidic radical which is written on the right. Step 2. Writing the valency below the respective radical. Step 3. Cross multiplying as shown by the arrows the number of the radicals. Step 4. After cross multiplication of valencies, write down the chemical formula of the compound sodium sulfate, that is we get Na2SO4. In order to write the chemical formula of compounds, it is necessary to know the valency of the various radicals. Thank you.